Thank you, Magdalena, for this introduction. Yeah, my name is Andreas, and before we dive deeper into this topic, I'd like to give you a rough overview about DH electronics. So first of all, we are developing customer-specific products. This is our main business and starts from the first idea together with the customer and goes over the development step and ends with the after-sales services with the production of the device over the years. Next to this, we have standard products like our DHMIs, touch panel computers, and the DHCon family with the DIN rail controllers and IoT gateways. And last but not least, we have our system on modules. So the solderable and the pluggable system on modules. And this is exactly my area of responsibility. So let's talk about the advantages of system on modules. First of all, system on modules can really speed up the time to market. With a system on module, you buy the complex parts around the system on chip directly with the module, and so you are much faster at the development steps. And because of the same reasons, the risks are also reduced. As I said, you buy the complex parts like, for example, DDR memory routing and things like this, and therefore you can really reduce the risks of the project itself. And overall, you can reduce the costs. This means in that case, you can reduce the development costs because you don't have to develop the parts around the SoC by yourself. You can directly buy this know-how from the system on module vendor. And also please think about the software parts here. You get a reference BSP from for this system on module. And if you select the correct SOM vendor, you will also get the software maintenance for the system on module. And this reduces the costs over the lifespan of the product because you otherwise have to do all these parts by yourself. On this slide, we like to have a look at the different categories which are available on the market of system on modules. Let's start with the first one, the individual form factor, the individual category. This means the system on modules have no pin compatibility and they are only available from a single vendor. This is exactly what we are doing with our DH Core system on modules. So an example here is our DH Core STM32MP1. The next category is the vendor standard. Here we have pin compatibility, but only this system on modules are only available from a single vendor. So you can switch between different modules with the pin compatibility, but only from a single vendor. This is an important thing here. An example here is our DHCom STM32MP1 system on module. And the last category on the market is industry standard. And here we have again the pin compatibility, but this system on modules are available from multiple vendors. Examples here are standards like OSM or SMARC by SCAT. And yeah, in summary, I can say each of these categories has its pros and cons. And yeah, we will have a detailed look about this on the next slides. Let's start again with the individual category. The big plus here is that typically all SoC functions are available on your mainboard. This means all functions are really available outside of the system on module. This is the big plus here. Then we have no additional costs due to compatibility with a standard. And the minus here is that this system on modules are typically only available from a single source, and this means they are not replaceable with other SOMs. Then let's have a look at the vendor-specific standard. Here the big plus is the replaceability with SOMs by that vendor. This means you can switch between different SOMs of that vendor within this specific standard. Then the next point is the low familiarization time. This means if your developers have done a first design based on this standard and they're doing a second one then this will really speed up your development time, because yeah, they know exactly what to do with this standard, and so this can really speed up the development step. Yeah, minus here is that with a standard you only have the family feature set available. Only this functionality is available outside of the SOM, so you will lose system on chip functionality. We have additional costs due to compatibility, and we have only a single source. This means this system on modules are only available from this specific vendor. The last category, the industry standard. So here the big plus is replaceable by SOMs with SOMs by different vendors. So this is, I think, the big plus here. Again, the low familiarization time. Again, only family feature set of this specific standard is available outside on your mainboard. And typically we have high additional costs due to compatibility with this standard. So as I saw in the past, the costs typically rise when a SOM needs to be developed according to an industry standard. So the cheapest solution is typically the individual solution, then the vendor specific standard, and the most expensive one is typically the industry standard. Now let's discuss my SOM selection guide. So in advance to this webinar, I thought about how to bring this topic to you. And I think the best idea is here to show some example questions, what you should ask in advance before you decide or before you select a specific system on modules. So we learned now which different form factors categories are available on the market. And now we like to have a look at some example questions which show you exactly what you should ask in advance. And these questions I have split it also in two categories. So the first are the SOM specific questions, and the second category are the vendor specific questions. Well, let's start with the SOM specific questions. So here are some examples. The first, are there special functions available from the SoC? What is required? So please think about what functionality is needed on your mainboard. So here are some examples: LVDS, display interface, dual Ethernet, and things like this, CAN interface, and many more. Think about this and ask about and ask your SOM vendor about what is really available. What quantities are to be produced? This belongs a lot to the form factor, maybe solderable, pluggable, higher quantities. If you have higher quantities, maybe a solderable solution is a good idea, and so on. Do I need a second source for the SOM? If yes, then maybe industry standard would be a good idea. Is it necessary to replace a SOM at a later point in the product term by a more powerful SOM or regarding some other topics? If yes, so it would be a good idea to select a standard. Then it is replaceable, vendor standard or industry standard. The installation situation and space requirements. So how does assembly look like? Do I need fully automated production? Can it be plugged, or does it have to be soldered down? So please think about this in advance and discuss this with your SOM vendor or your preferred SOM vendor. And then let's talk about some questions from this category with hidden cost topic. The first is, do I have to cool the CPU? If so, how is it possible with the selected SOM? I will show you later an example from the H electronics, how simple cooling could be. But this is really a hidden cost topic, because I also saw on the market expensive heatsinks which must be mounted in a very complex way and things like this. So please think about cooling it in advance. How does the power supply concept of the SOM look like? So this we will also later discuss on a specific slide. Yeah, you can really reduce the costs if you have a good power supply concept. Do I need low power modes? And if so, are they supported? And what values do I get down to? So this is in many, I think this is more or less a software topic here. But if this is really needed, please ask about in advance. Otherwise, you have to implement this by your own, and this means a lot of work to do. So yeah, please ask in advance about this. Now let's have a look at the vendor-specific questions. Here are some examples. The first one, do I know exactly which SoC I want to use? If not, which processor or GPU performance do I need? So in the past, I often saw that potential customers comes to me and we discuss about the requirements of the project, and they told me, yeah, they like to use the i.MX8 as example. And if you have a detailed look at the requirements, we saw that the i.MX8 is a great CPU, but a great SoC, but for this project, it is not really needed such performance. And so they can really reduce the costs by choosing a different SoC. So please clarify this in advance. What about long-term availability? Yeah, it's an important question. So what does the SOM vendor provide here? PCN and end-of-life handling, it's also a very important topic over the lifetime of your product. Which operating systems are supported? Yeah, if I need Android as example and the SOM vendor doesn't provide Android support, maybe then it's not the best choice. Then we have here again this hidden cost topics. So the first question here is, which specific software components are needed? Examples here are browser, Yocto, Buildroot, Debian, Qt, and many more things. Especially the software topics can create high additional costs, I think. So if you find a SOM vendor which can offer your needed components out of the box, I think this is really a good idea. And so please discuss this before you start your project. Are there customer specific variants of the SOM available? Yeah, this is a good idea if you like to reduce the costs if it comes to higher quantities. So maybe if the SOM vendor offers specific customer specific variants, yeah, it's a good idea. Is the software really open source? In that case, in the case of Linux, does the vendor provide mainline support for the SOM? This will be explained in detail in an additional slide. I think this is a big topic and very important to keep the device up to date over the lifetime. How often does the SOM vendor provide software updates? Yeah, it belongs a little bit together with the point before. Which update mechanisms and possibilities are provided with the selected SOM? So yeah, it's also a software topic here, but you should discuss this before you start your project. Which services, most of all, support does the vendor provide? Which partner network does the vendor provide? How do I install the initial software? Is it possible to buy pre-programmed SOMs? Yeah, this is also a good idea if this is supported from the vendor. Now I like to discuss some specific topics with you, and let's start with the topic power management. So here we have again different categories available on the market. The first is the discrete power management. This is the cheapest solution. We have no low power mode support and also no dynamic voltage and frequency scaling support. The second solution on the market is a PMIC based solution. This means with Power Manager on the system on module. Here I like to say first, please check if there is a working Linux driver available. If not, you can compare this directly with a discrete solution, or you have to implement the driver by yourself, which means I think a lot of work to do. But if there is a Linux driver available, everything is fine and you can support low power modes and DVFS. But with such a solution, you have no mainboard power control via the PMIC. And this becomes more clear if we have a look at the last category, available on the market. This means PMIC plus mainboard power source. Here it's again the same. We have a PMIC on the system on module, so we can support low power modes and DVFS. But next to this, some output rails of the PMIC are fed back to the mainboard. And this means the power manager on the system on module can also supply the components on the mainboard directly from the PMIC. And this is really a cost-efficient solution because you only need a single regulator on your mainboard for the system on module supply. Then you can also optimize your mainboard design based for a low power mode design because, as I said, the PMIC outputs are fed back to the mainboard, so you have full control also of the power supply on your mainboard directly from the PMIC. So you can use the Linux drivers to switch off some power rails if you enter low power mode, for example. And also the power sequencing becomes much more easier because you only switch on the power supply of the system on module. This is directly routed to the PMIC, and all the rest is done directly from the PMIC. So the PMIC is also doing the sequencing of the mainboard power supply. On this slide, I'd like to show you an overview about the power management of our DH-Core STM32MP1 system on module. Here we have only a single 5-volt supply. This is directly provided to the PMIC, and then we have multiple outputs of the PMIC fed back to the mainboard, and this can exactly be used on the mainboard to supply the whole mainboard. And we have also some additional features like power switch for USB directly included in the PMIC, and also some LDO output. So in summary, we can say we only need a single 5-volt supply, and that's all for the mainboard. The rest is done from the PMIC, and this is very easy and cheap solution. Now we like to have a look at the cooling topic. So as I said before, cooling can create really high additional costs because the production process is complex, or the heat sinks are really expensive, or the solution needs a lot of space and things like this. And so I like to show you our DH example, how simple and easy cooling can be. And this is our so-called 5-cent cooling solution. And this is really a time, space, and cost-saving solution. And yeah, let's have a look at this example here. So we used the STM32MP1 in a closed box. And as you can see on the right side, we mounted the CPU with our DHCOM STM32MP1 system on module on the bottom side of the SOM. And so we had the possibility to connect the CPU with a simple gap pad to the mainboard. So we can transfer the heat from the CPU via this gap pad to the mainboard. On the mainboard, we have a copper pad without solder resist. It's not an inlay, it's a standard copper pad of your top layer without solder resist. In the copper pad, we have included standard wires which are connected to the internal ground plane, and that's all. So you can transfer the heat from the CPU via this gap pad to the mainboard and via these wires to the ground plane, and then you can spread the heat over the whole mainboard via the ground plane. In the example on the left side, you can see some temperature numbers. We have done a test in a closed box, and we started a stress test on the STM32MP1, and with an ambient temperature of 23 degrees, the CPU gets 89 degrees hot. Only by adding this simple gap pad, we can reduce the heat to 74 degrees. In a second step, as I said, we have used standard wires on our mainboard, so we can again place on the bottom side of the mainboard again such a copper pad without solder resist, and so we have the possibility to connect the bottom side of the mainboard to a mounting blade or housing or whatever. In this example, we connected the bottom side with a second gap pad to a mounting plate inside this closed box. And with this second gap pad, we reduced the heat to 66 degrees. And yeah, I think this example shows you how simple and easy cooling can be exactly with such ARM-based system on modules with a typical power consumption up to 5 watts. The next topic is open source. So I think this is a really big topic here. Please have a detailed look at the software parts, because software can really create hidden costs or additional costs in your project. Open source basically means that all sources are really made available, but we must also have a look at the license topic. And if we have a closer look to the Linux kernel, we see that the Linux kernel is licensed under the GPL v2 license. And this license tells us that the sources are really made available, but also any of its modifications. And this brings us to the topic mainline Linux. With mainline Linux, really all optimizations, improvements, bug fixes are available to anyone. Mainline Linux is not like a vendor kernel, which is typically provided from companies like NXP or ST. And in that case, only a single company is working on this solution. Mainline Linux is really different here, because all these optimizations, improvements, which are done from the whole community around the world, are available to anyone. This is a big plus here. And yeah, for this, the SOM support that you're really able to use mainline Linux, the SOM support must be upstreamed to mainline Linux. And yeah, this is not possible directly for a SOM, because a SOM is not an end device. So the upstream support is typically based on a development board or reference design. This is exactly what we are doing as SDH. And if this is available for a system on module, you can directly use Linux Next for this SOM. Linux Next is the latest available Linux kernel version. If it comes to mass production with an embedded device, you will typically stay on a long-term support release. Today we have the 5.10 or 5.15 kernel. But in summary, we can say with the mainline Linux solution, you really have no dependency to the SoC vendor itself. This is no vendor kernel, it's mainline Linux here. And next to this, I think it is very important that the SOM vendor is doing an active maintenance of the upstream support for this specific system on module. And this can only be done from the SOM vendor, so ask about this. It's important that this is done over the lifespan. And the result is that the BSP contains only a few upstream backports and SOM vendor specific patches, and that's all. The rest is mainline Linux. And this helps you that your device stays up to date and secure over the time. And in best case, maybe you can also upstream the device. So maybe you can upstream also support directly for your end device to mainline Linux. And then it is the easiest way for you to keep your device up to date over the time. But I know that this is not possible for each project, but maybe you can discuss this. And if it's possible, I think it's the easiest way to keep your device up to date over the lifespan. The next topic is solderable or pluggable system on module. And here we will have again a look at some example questions. So the first here is how many pieces should be produced per year. If it comes to higher quantities, I think a solderable solution makes sense. For lower and mid quantities, a pluggable solution is also a good choice. The next question is a specific connector available and at what price? So for a pluggable solution, please check the connector types, the availability and the price level. What space is available for the system on module in my device? So if you have low space, I think a solderable SOM makes sense because it comes typically with a smaller footprint. Do I have to be able to exchange the SOM in mass production device? If yes, so the answer is easy. So then you have to use a pluggable SOM. And the last question, can my EMS provider handle the soldered down system on module? And here we like to have a look at the LGA solutions, the land grid array solutions on the market. Here you can see a solution without pre-tint pads, and this we as DH Electronic really not recommend, because yeah, it is not a safe solution for the production. So we as DH Electronics recommend pre-tint LGAs, and the reason here is without pre-tint pads, you have to put more solder paste to your mainboard to compensate the PCB roughness, and this can result in the risk of air bubbles inside solder balls, and this can lead into a bad connection. And to avoid this, I would really tend to the right hand side to the LGAs with pre-tint pads. So this is exactly what we are using with our DH core system on modules. Okay, now let's do a short summary about this webinar. So as we learned before, we have different type of categories of system on modules available on the market. On the left-hand side, you can see the individual solutions. On the right-hand side, you can see the standards, the vendor or industry standards. With the individual solution, the big plus is we have access to all SoC features. This is really great because you must think in advance about the feature set. If this is available or usable with the specific system on module, you can directly focus on the features of the SoC itself, and all features are really usable on this with this specific system on module. This is big plus here. We have lowest costs for high quantities with the individual solutions. Typically individual solutions are most of all I see soldered down system on modules. This is exactly what we are doing with our DH core family. And on the right hand side we have the standards, the vendor standards, the industry standards. Here we have the compatibility, the scalable family concepts. This type of system on modules are more flexible, especially for low and mid quantities. And I think a big plus is also the shorter training period for developers, especially if you're doing several designs based on the same standard. So yeah, I think this is a big plus here on the right hand side. On the last slide, I'd like to give you an overview about our products. As I said before, we as DH are developing our system on modules based on individual designs and vendor standard. Today we have no system on modules which are developed according to an industry standard. Let's start with the left-hand side. Here we have our DH core system on modules. These are individual designs, which means we have no compatibility between the DH core system on modules. And the main features are low costs. Therefore, we are using the soldered down technique, and the SOMs are really offer the full SoC feature set on the mainboard. Next to this, we have our DH-COM family on the right-hand side. Here we have a flexible family concept, means all DH-COM system on modules can be used in a single mainboard, which is designed according to the DH-COM standard. This is perfect for low and mid quantities. As connector, we are using the well-known SODIMM 200 with an additional Molex high-speed connector. The additional connector is only needed if you need advanced interfaces like PCI Express, USB 3, or as example HDMI. Therefore, you can reduce the costs if you only need standard interfaces, because you only need then the SODIMM 200. Here I also like to mention that the SODIMM is developed for the portable computers like laptops. Therefore, the connector fits perfect for products which has higher shock and vibration requirements. Next to this, it is a cheap connector. So yeah, please think here on the hidden cost topic from before. So cheap connector is always good. And at the end, I also like to highlight our newest member of the DHCOM family, the DHCOM i.mx8m+. Here we added also some special features like dual band Wi-Fi on the SOM with chip antenna, or also the possibility to connect an external antenna. Next to this, we have the possibility of dual gigabit Ethernet and also 2 USB 3 ports. And we added an additional display bridge, which offers standard RGB interface with the i.mx8m+ and also an optional DisplayPort connectivity. Overall, the SOM is very flexible and can be configured to your needs with our customer-specific variants. But this configuration possibility applies to all our system on modules. So that's all from my side. I hope you've learned a lot, and if you have any questions, I would be happy to answer these questions now. Please simply enter your questions to the chat. And yeah, so thanks for your attention.